Welcome to 5-Minute BTech channel. Today, we're going to pull back the curtain on your computer's operating system. We're going to see how it acts as this ultimate invisible gatekeeper for every single app you use. I mean, have you ever really stopped to think about that? You click save on a document, or maybe your favorite game connects to the internet. How does that actually happen? It's definitely not magic. And trust me, your apps are not doing it all on their own. There is a super powerful entity right in the middle making it all possible. So to get to the bottom of this, we're first going to look at the OS's big job as a gatekeeper. Then we'll break down exactly what system calls are. And finally, we'll explore the two main kinds of services the OS provides, which, I like to think of as its butler duties. All right, let's jump right into our first section. See, the entire relationship between your apps and your computer's hardware, it's all built on one simple, non-negotiable rule. And that's it. A program like your web browser or a video game is absolutely forbidden from talking directly to your hard drive, your network card, or your memory. And this is a really crucial security and stability feature. I mean, can you imagine the chaos if any old program could just start writing data wherever it wanted to? It'd be a complete mess.
Okay, so if programs can't touch the hardware, how does anything ever get done? Well, they have to go through the official front door. They have to politely knock and ask the gatekeeper, the operating system, for permission. And that formal request has a name. It's called a system call.
The best way to think of it is like this. A system call is the official language programs have to use to ask the OS to do something important for them. It's the standardized, totally safe, and controlled way to get access to all the powerful stuff on the machine. And this isn't some abstract techie concept. These are things you see happen every single second. When you open a document, that's an open file system call. When your computer slows down because you have way too many tabs open, that's your browser making a whole bunch of create a new process system calls. What's really cool is how organized this whole thing is. These thousands of possible requests, they're not just a random mess. Nope, they're neatly sorted into categories. You've got calls for managing files, for controlling processes, for talking to devices like your printer, and so on. It's a really well-structured system. So now that we know how programs ask for things using system calls, let's look at what they're actually asking for. This is where the OS kind of shifts gears from being just a strict gatekeeper to also being a super helpful butler, providing all these essential services for your programs. And first and foremost, the most fundamental service of all, actually running the program. When you double-click an icon, that's when the OS butler totally takes over. It finds the program on your hard drive, it loads it into the computer's memory, starts it running, and then just watches over it until it either finishes its job or crashes. And if it does crash, the OS is the one that cleans up the mess. Next up, we have handling all the input and output, or what we call I/O. Think about it. Every single keystroke you type, every pixel that shows up on your screen, every little byte of data read from your storage, it's all being managed by the OS. Your application just says, hey, OS, I need to read this file. And the OS handles all the complicated, low-level details of making the disk drive actually find that data. And speaking of files, that brings us right to the next major service. And boom, this right here directly answers that question we started with. When you hit save, your word processor makes a system call, and it just hands the data over to the OS. The OS then does the whole file system manipulation service. It creates the file, writes your data to it, and puts it neatly in the folder you wanted. But what happens if programs need to talk to each other, not just to the hardware? Well, you guessed it, the OS handles that too. Now, what's really interesting here is that there are two main ways the OS does this. It can set up a shared space in memory where programs can just leave info for each other, which is super fast. Or it can act like a little mail carrier, delivering messages back and forth between programs, which is often a whole lot safer. So those were the core services that help individual programs, but the OS butler also has this whole other set of duties, managing the entire system to keep it running smoothly, fairly, and securely for everybody. These are the crucial jobs happening in the background. The OS is always on the lookout for errors. It's also the ultimate referee, deciding which of the dozens of running programs gets to use the CPU at any given millisecond. And it keeps track of everything, which is really useful for monitoring how the system is performing. And this leads us to the final and, maybe the most important service of them all. This is really where the gatekeeper and the butler roles come together. The OS acts as the ultimate guard for your entire digital life. It enforces file permissions, it manages your logins, And most critically, it builds these virtual walls between programs so that a crash in your web browser doesn't bring down your entire computer.
And that quote really just sums it all up, doesn't it? The operating system is both a helpful provider of services and a strict enforcer of rules. It basically creates the stage for your programs to run on, and then it acts as the director, the stage manager, and the security guard all at once, just to make sure the show goes on smoothly and safely.
It's a pretty wild thought, right? Every single time you move your mouse or connect to Wi-Fi, there's this complex, totally invisible dance of system calls and OS services making it all happen behind the scenes. If you like the video, hit like and subscribe the channel, and I'll meet you in the next video.